So I'm assuming you've seen the compound angle formula or all the different parts of it, but seeing it in action might make it more understandable. So I'm gonna do a quick example on sine and then another on cosine. So the idea is that you can split the angle up either as an addition or subtraction, and by splitting it up into two different numbers, the other numbers are easier to calculate, especially if you're dealing with, for example, a non-calculator paper. So say 75 here, I can split the 75 into 45 and a 30, and these two are part of the exact angles that you should already know as a student, so then it would be easier to calculate. So using the sine rule, so the compound angle formula for the sine rule, it's sine a plus b. We're going to use the addition one, and the addition tells you that this will be sine a cos a plus, sine a cos b, and then cos a sine b. So what we're doing 45 and 30, so I'm just going to put them in there. So I have cos 30, cos 45, and sine 30. So evaluating all the numbers and knowing them from the exact values table. For sine 45 and cos 45, you can either use 1 over root 2 or root 2 over 2. Either would be equal. So root 2 over 2 is equal to 1 over root 2. You can use either. Both answers will be correct. So say I use root 2 over 2, and then cos 30 is going to be 1 over 2 root 2, and then this will be the same, and then sine 30 will be just 1 over 2. And these are all being multiplied by each other. Sorry, I skipped ahead. The cos 30 is root 3 over 2. Okay, so multiply, simplify, and you should get, let's keep these as root 2, root 3, and so this will be 4, and then root 2 over 4 as well. They have the same denominator, so I have root 2, root 3, plus root 2. I can take root 2 as a common factor, and I have root 3 plus 1, the whole thing over 4. So quite nice and simple, and it's a quicker way, especially if it's a non-calculator paper, to calculate this root of the sine of 75, because you wouldn't memorize what sine of 75 is. So another way to use it is when you're given such information as this. So you have A is an obtuse angle, and sine A is 3 over 5. B is an acute angle, and sine B is 5 over 13, and you need to directly calculate cos A minus B. So cos A minus B, I need to use the second formula, which if I'm subtracting in the angles, then I need to add between these two terms. Now, one thing to note is the information about the obtuse and the acute. So if sine A is an obtuse angle, giving me 3 over 5, it means I'm in the second quadrant. So in the second quadrant, my cos is negative. So that's one thing to note. Another thing to note is if B is acute, so sine B is 5 over 13, it means I'm in the first quadrant, which means my cos is positive. Now this is important because if I'm going to use this formula, I don't know what cos A and sine and cos B are. I only know the sine. So let's write them up first before I discuss how the cos is calculated. So we have cos A, we don't know what that is. Cos B, it's a plus here. If you picked up plus, then this will be a minus. Then sine A, I could just directly write the numbers. Sine A is 3 over 5, and sine B is 5 over 13. Okay, so how do we find these when we only have sine and when we only have sine as information? This is already done in a previous video, so if you need more details about that, I explained it using two methods. So just have a quick look at that video. I'm going to link it in the description, but just the quick method is either use a right angle triangle or use the Pythagorean identity, which is cos squared theta plus sine squared theta equals to 1. So directly just use it by substituting in here, rearranging, make cos theta the subject, and that would help you find the angle. But I do want to discuss how it is with the negative, and then I'm just going to directly give the answer here. So if I want to find, if I have that sine A is 3 over 5, then cos theta, if you follow from the other video, it's going to be the root of 1 minus 3 over 5 squared. And if I get the answer to that, it's going to be 4 over 5. Now, 4 over 5 is the value of cos in the first quadrant. What I want is the cos in the second quadrant, and cos will have to be negative. So this will have to be negative. That's all you have to do, is just switching the sign. With this, because it's the first quadrant, cos is positive, so whatever answer you're going to get, you're just going to go do the same thing, 1 minus 5 over 13 squared, and just keep the answer as positive. So with this one, I have 4 over 5, and with the other one, I will get 12 over 13. And then do the maths, simplify. Things will cancel out here. Things will not cancel out here, so you'll have to do the maths there, and you will get negative 33 over 65. So that's the value of cos A minus B. And we don't even know what angle A and angle B are, but we were able to calculate it just using this information, just using the sine information.